בינה מלאכותית, זה ישתלט עלינו, זה לא ישתלט עלינו. אני יכול להגיד לכם שבשנה האחרונה אני עושה המון הרצאות על בינה מלאכותית, ואחד הדברים שאנשים אומרים לי כל הזמן זה, חוץ מזה שוואו, איזה חתיך אתה, והקטע עם רלי זה באמת רציני, אנשים אומרים, אני לא מבין את כל העניין הזה של הפחד מבינה מלאכותית, מקסימום אם זה ישתלט עלינו, אז נוציא את השטקר. אז באמת זאת שאלה, האם אפשר להוציא את השטקר, ומה המשמעות של להוציא את השטקר? האם אפשר לבוא ולהגיד, טוב, אם אנחנו מרגישים שהאינטרנט משתלט עלינו, אז נוציא את השטקר? אי אפשר להוציא את השטקר, אפשר לבוא ולהגיד שאנחנו הולכים ליער, ואנחנו מנתקים את עצמנו מהציביליזציה המערבית, אבל כמו שברור לכולם שציביליזציה מערבית היום לא קיימת בלי אינטרנט, אולי כבר הגענו לשלב שהיא לא קיימת בלי בינה מלאכותית, והדרך היחידה להוציא את השטקר זה לא לעשות הדרת AI, אלא להדיר את עצמנו לאיזה מקום שאין בו שום דבר. וכדי לדבר על הנושאים האלה, הבאתי בן אדם שהוא ממש מומחה בתחום. עכשיו, איך אני יודע שהוא מומחה בתחום? כי הבן אדם הזה בתור סטודנט בן 19, הצליח לקחת את המערכת של GPT-2 ולעשות לה reverse engineering, זאת אומרת לבנות אותה from scratch מהחדר שינה שלו. קוראים לו קונור ליי, ויש לו דוגמאות, ויש לו רעיונות, ויש לו תובנות מרתקות על כל עולם הבינה המלאכותית, ועל עולם הבינה המלאכותית הכללית. זאת הייתה שיחה מרתקת שנגעה בטכנולוגיה ובפילוסופיה ובאיך צריך ללמוד ולדעת ולהבין, באמת היה מרתק בצורה בלתי רגילה. וכמו תמיד, אם השיחה הזאת מעניינת אתכם, אתם מוזמנים ללחוץ על הסאבסקרייב. למה? כי ככה האלגוריתם AI של יוטיוב ידע להביא את השיחה הזאת לעוד אנשים חכמים ומוצלחים כמוכם. אני יודע שהשיחה היא באנגלית, אבל הוא מדבר אנגלית במבטא מאוד מאוד טוב, כי ככה זה בגרמניה יש חינוך נהדר. אז עכשיו, קונור ליי עם תובנות שמפילות את הראש. Conor Leahy, thank you so much for coming. How are you today?
I'm doing great. Thanks so much for having me on.
Yes, it's my pleasure, and we have so much to discuss about, but I think that we need to start at the beginning, okay? Now, the first piece of information about you at your Wikipedia page is, and I quote, in 2019, Lay reverse engineered GPT-2 in his bedroom and later co-founded Eleuther AI to attempt to replicate GPT-3. So with your permission, I would like to focus on, reverse engineering GPT-2 in the bedroom for the time you were a student at Munich University. So if you please can elaborate on this very bizarre piece of information.
Yeah, I feel the story kind of has gotten retold a little bit through the media over and over again. That like some of the details surprise even me. For one, it wasn't in my bedroom. It was actually at the university in a TD study room. But I mean, it doesn't matter. Just a small detail there. So the main basic thing what happened here was that so I've been really interested in AI and AGI. So it means human level and superhuman level systems, kind of like since I was a teenager. I kind of got into this because I was asking myself a question like, how can I solve the most problems? How can I help the most people? And what I was thinking is that, well, I could become a scientist, right? Maybe I could work on climate change or cure cancer or something. But what would be the best thing for me to invent? And then I thought, well, if I figure out science and intelligence, well, then I can automate science and then I can solve all the problems. So I'll go do that. So if I just build AGI and tell it to solve all the problems and I solve all the problems, great. So I should go do that. So this is how I kind of got into AI. I then later, was read how some like early AI safety people talked about this topic where the real hard problem of AGI is not how to build it, it's how to control it, which made obvious sense to me. I was like, oh, duh, of course. That's the hard problem. So I'm going to go work on that. So at this point, I'm already like thinking in this direction, already care about this a lot. But at this point, I really still think we still have quite a bit of time. Like these are the days where like AI systems are still very brittle. They're very like single focused for like every application you had to retrain and like tweak architectures from scratch and so on. It was like, it was impressive. You had your AlphaGos and whatnot, your OpenAI 5s, but it still was like it still felt like AGI was like pretty far away. And that all changed basically with GPT-2. So when I first saw GPT-2, which, by today's standard is kind of like a not very impressive thing, and I got it running on my laptop, like the 100 million parameter, like the smallest version of it, and it could barely string together a couple of words coherently. And I remember just seeing it and being like, "Oh fuck, this is it. This is going to become AGI. It's not there yet, but this is the missing ingredient." Because it was a general purpose pattern learner. You could just give it massive piles of garbage data and more compute, and it learned more and more complex patterns. And this was from my point of view, kind of the missing point piece to AGI that didn't exist previously. So I was like, well, shit, crunch time is now. So the first thing I need to do is try to understand this. And I thought, what better way to understand it than try to build my own? So I kind of gathered every scrap of code, every paper, every blog post, everything I could find to try to like reconstruct how this thing worked and make my own. And then there was this just crazy coincidence that it happened at the same time to get access to like an academic access program to like a massive amount of computing power from Google, like cloud computing power, and which would allow me to actually do this. And so I did. And this then led to kind of a longer digression and like, should I release this? Should I not release it? I ended up talking to people at OpenAI, people in the open source community, and so on. What are the pros and cons? Because at this time, GPT-2 was not publicly released. It was because of security concerns, which nowadays seem quaint, but at the time was a completely reason new system. I basically ultimately decided, out of respect, to not, even though I didn't think it was a dangerous piece of software. I'd want to respect the norms of like, hey, just because every time a lab might have security concerns, it might be good not for some hacker to, humiliate them online. That seems like a really bad precedent to set. So that's the short of kind of like what happened there.
I want to mention two things to my viewers. Now, if you're familiar with, there is like the YouTube channel of Andrew Karpathy, and he goes step by step in how to build your own GPT. But in 2019, those videos were unavailable yet. Hence, what you did is uh, just remarkable. I need to come up with a better adjective, but mind blowing. Okay. And this is number one. And number two, where did you get all the data? All, the garbage data, all the data that GPT was trained on?
I scraped it all myself. That was part of the project. So I wrote my own scrapers. So the original GPT-2 was trained on, they scraped all the links from Reddit that had at least 3 upvotes, and then scraped the websites that those links linked to. And so I did all of that by scratch, by hand, and just like got a bunch of cloud servers, like hundreds of them, just for like a couple days to just like crawl the whole thing. So that was part of the project. So I made my own data set. I wrote my own training loop. I got the model architecture, which like at the time there was like multiple things about the architecture that were like unclear. Like in particular, I actually made a mistake in the architecture, which led to my model being less good than the actual GPT-2. I did drop out slightly differently than they ended up doing it, which harmed performance of my model, and like a couple other facts like that.
Wow. Wow. So GPT-2 wasn't trained on the data of Wikipedia, just Reddit.
Um, nope, just Reddit as far as I remember.
And
Maybe
I
there
think,
was, I assume in practice there's a lot of Wikipedia in there too,
yes,
but at least for the version that I built,
yes.
which I tried to replicate the paper as closely as possible, that's kind of what I did.
I think that it leads me to my next question because basically what you're saying that those capabilities are beyond imagination. I spoke with Professor Regina Barzilai from MIT University the other day, and they managed to replicate AlphaFold 3 basically and make it open source just with the students and massive computing power. So the idea is that you can take a graduate computer science student with a mediocre knowledge of biology and chemistry, yet help he can build or re-engineer the AlphaFold that got DeepMind into the Nobel Prize in chemistry. So I think what you just said is profoundly true. If you can work on intelligent systems that are truly intelligent, you can just, build whatever you want.
Yeah, there's this. So I wrote a blog post about this recently. There's this thing that I call the strange decoupling, which we could also talk about why that is maybe a bad thing. But there's a strange thing that happens with AI in particular, where your understanding of the system becomes decoupled from its capabilities. In the past, if you wanted to write the best protein folding algorithm, you had to really understand protein folding quite deeply. You have to understand the mathematics, you have to understand proteins, you have to understand the experimental design. And so you had to know a lot about that. That's no longer really true. You can now, like there's some of this, of course, is true. I'm sure a lot of the people who worked in AlphaFold were brilliant biologists and so on. But like ultimately, the actual way these systems solve these problems is unclear. Like it's not clear how AlphaFold really solves it, right? It's a big blob that like, and so you can get a grad student who might, no disrespect to this grad student by any means, but like, probably doesn't know a lot about biology or it's not a Nobel Prize winning biologist, but still can get the kind of capabilities without the necessary understanding. And this is quite different from a lot of like basically all other kinds of science. Like if I met someone who built the best airplane in the world, the fastest, most maneuverable airplane in the world, I would think he must know the most about airplanes in the world. He probably knows more about airplanes than I do. But funnily, with AI, that's not necessarily true.
There is a great quote from Elon Musk that said, "We have Tesla and we have SpaceX, and we have all the algorithms that we are using or utilizing in Tesla are deep learning basically, and we are not using deep learning whatsoever in SpaceX." And this got Elon Musk to wonder why it's not that Elon Musk is against deep learning or AI, but how come SpaceX doesn't apply any artificial intelligence algorithms? And he came to the conclusion, I don't know if it's right, because he said Tesla is uh, dealing with human beings, and SpaceX we're dealing with machines. And when deals with a machine, with a different machine, machine learning is unnecessary. We don't need it. We can just quant the number and we can do the equations. But if your system should interact with an human agent, you must have this AI in the middle. So I would like to ask you about this strange decoupling, because I teach my students all the time that the main difference between machine learning and deep learning is exactly what you said. Because in machine learning, we had this expert that can grab or extract the relevant features for the problem. For example, in face detection, we have the sift and we have the gradient over here and over here. But many people say that in deep learning, we get all the raw data into the system, meaning pixels, meaning a, wave sounds, etc. Just the bare raw features, and the deep learning is learning how to extract the relevant features. So how the difference between machine and deep learning in this context is different than strange decoupling that you just mentioned.
I think it's a very closely related or it's kind of the same thing, right? It's this thing of like, so there is a thing which I think there is no satisfying theoretical explanation for, where there are certain tasks where just like we can't solve them with normal programming in practice. And it's kind of unclear why. Like, at least to me, it's kind of unclear. For example, dog detecting or like bird detecting. There's an old Ace KCD comic where they have the two characters talking about like how it's very unintuitive to tell people what is easy and what is hard for a computer. Where like the one character asks the other character, can you make an app, where it detects whether you're in a national park? And the programmer is like, well, yeah, we just hook it to the GPS system, check it against the national database, shouldn't be a problem and take it and check if there's a bird in your picture. And the character's like, oh, that's going to take 5 years of development and a whole research team. This was before deep learning. And so if you try to just like C++, to like just like hand code a bird detecting algorithm, that would be just incredibly hard or impossible. But with a neural network, it's actually kind of easy nowadays. Like nowadays, our standard vision networks are just really good. And just, you get a bunch of pictures of birds and it's fine. It just works. And it's kind of unclear to me why some problems have this shape and why some don't. Like there's other problems, like formal problems. strict mathematical and logic problems that usually are much easier to solve in concrete code, like memory management or stuff like this, right? Like or sorting lists. You would never use a neural network for this, right? Like, why would you? Just do it in code. And I think this is actually kind of an unsolved question in computer science. Like, I don't think anyone has an answer for like why these are different and what problems are in one category versus the other category. It's clear that a lot of human problems are in this neural category. Like a lot of the interface between humans, language, vision, motion seems to be like in this like neural blob of problems that like normal code has difficulties interfacing with, but like deep learning for whatever reason can more easily interface with. You know, maybe it's because we're just not good enough at programming. You know, maybe if our experts knew the right, signals to extract and the right code to write, maybe it would work. I don't know. But at the current state, yeah, there's this weird world where there's these formal problems, like normal computer science problems that you solve with code. And there's all these other problems that we care about where deep learning can solve them, but in ways we don't necessarily understand.
Definitely. I have a theory, and since I often lecture to the general public about artificial intelligence, I had the very same issues that I had to address in my lectures, and I think I came up with some things that later on I spoke with Professor Moshe Vardi, and he told me that he thinks basically the same. So first of all, it's very hard for the lay public to understand that distinguish a dog from a cat is a much more complex problem in terms of searching space than playing chess. This is very, very unintuitive because only smart people can play chess, but everyone can distinguish dogs from cats or from birds, or, distinguish 6 from 5. So it's very unintuitive. And the second thing is that I want to come back to the book by Danny Kahneman, Thinking Fast and Slow, where he basically splits the brain into 2 systems. So the system 1, which is learning by rules, is the things that computer science can do great. But learning from experience, which is walking, seeing, all the vision and talking, all those things can be encapsulated into system 2. Now, system 2 is very intuitive. We don't make any mental effort when we see or when we walk or when we think about what the next word that we are going to speak about. So I think that system 1 versus system 2 can help us understand the differences between what kind of a problem does a neural network can handle well, and what kind of a problem I will let the traditional computer science algorithms to handle. Would you agree?
I think this is points at the same intuition, but I don't think it's not formalized. Like
No.
it is,
No.
if every time a new, like for example, it wasn't clear whether protein folding would be a system 2 or a system 1 type problem until
Definitely.
so this is the thing that I find curious is that it's still not clear. Like intuitively, yes, like system 1, system 2 get this intuition, but it's only an intuition. This is not formal, at least to my awareness. I don't know of anyone who has a formal theory of what the actual, like who can predict whether a new problem domain will be amenable to, system 1 or system 2 type thinking or not. At least as far as I'm aware, there's no like formal computer science theory that like explains this. So it's kind of like empirical, which is
Yes.
why so many people are now applying deep learning to all these different fields. And some of them are finding huge success and others don't work.
What you said is very deep. I need to think about it because we didn't know in advance if protein folding will be system 1 or system 2. This is a very, very interesting thought, and I need to think about it later on. Okay. Now, let's move on. Scott Aronson told me basically that, generally speaking, the political right is more obsessed with the AI alignment problem, and the political left is more obsessed with the AI safety and AI ethics. Now, do you also see this distinction between AI alignment versus safety in the political context? And can I consider you more as a AI alignment kind of a guy?
So I think there's obviously everyone has their aesthetics. There's left code aesthetics around AI. There are right code aesthetics around AI. I ultimately consider myself just pragmatic, in the sense that what I care about the most is, or what I think is the most concrete thing that will kill us, like in the short term, is AI superintelligence, or AGI, ASI. I think these are the thing. This is the most pressing problem. That doesn't mean that other problems don't exist. I just recently wrote a whole blog post about how the AI slop problem is a generalization of the same problems that we are facing with AI alignment. These are not separate problems; these are related problems, and so is
Could you
the
please
recommend.
elaborate on the AI slow, because we
Mhm,
discussed so many times the AI alignment problem in this channel, but I
mhm.
think we rarely touch upon the AI slow problem. So if you could please say a few words about the AI slow problem.
Yeah, so intuitively, we all know this, right? We go on our Facebook feed, or we Google image search something, and there's a bunch of AI generated slop, just like low effort, not like just like annoying images, or like deceptful, or just like not actually true images, right? Sometimes they're maybe funny or like kind of interesting or whatever, but in some sense they're like slop. Like it's not real. It's like distracting. It's like pollution is the way I would see this. And like I think everyone feels this intuitively. And so, as I said, I wrote recently a blog post where I go into this more in depth. Is that I think this intuition points at something actually very deep. I think there's something very, very deep at the heart of AI. So there is people more on the AI alignment, super intelligence kind of camp of things sometimes are extremely dismissive of like artists caring about AI art, displacing things, blah, blah, blah. I personally am much less dismissive of this. I think they're pointing to something deep. Like yes, labor markets change, blah, blah, blah. AI art tools will be part of artistic movements of the future, the same way the photograph was. Sure. We all agree with this. But there's a deep there's a deep, deep pattern that people feel viscerally, and at least I have seen only a few people like Eric Hole kind of like talk about more explicitly, which is that it is pollution. It's like, so when let's talk about complexity for a second. So the generalization, in my opinion, the generalization, if you take AI alignment and you generalize it, and you generalize it again, you generalize it again, you generalize it again, you generalize it again, what is the most general form of the problem we're talking about? And I'll claim that one of the most general phrasings of the problem is the problem of complexity. Well, so what I mean by this is that when you develop a software system, and you add new features, you add more code, your system becomes more complex. You have more things interacting, you have more places that can be bugs, you have more things that can break, you have more places where hackers can intervene, or and so on. So as your system becomes more complex, and there are things you can do to manage this complexity. Basically, all of software engineering is about ways to manage complexity of growing systems. This is most visible in software engineering, but actually it applies to all engineering systems. Like the reason we use standardized steel when we're building bridges is because this lowers the complexity. If every one of your steel bars has a different strength index and they all interact differently, this would make building a bridge hell. This would make it extremely hard to build a safe bridge. So
Now
we put a lot of,
it might be a better bridge in some
yes,
aspects, but the
yes,
complexity is not worth it. This is basically
exactly.
what you're saying. I might get
Mhm.
some benefits out of this complexity, but basically I cannot handle it.
Yes, and in practice, usually you don't get benefits. Usually you break things. So like there's a saying in computer programming where if you make a program that's as complex as you could possibly program,
You
then
cannot
you can't
debug it.
debug it. Then you can't debug it because you have to be twice as smart to debug whatever you can build. So this is a huge problem that generalizes across all of engineering. This is not a problem just from software. It's just most well known in software context, but it actually applies to all forms of engineering. Whenever you're building a complex engineered system, the thing is that you have to be able to predict what the system will do. That's what engineering is. It's like if I build an airplane, I want to be able to know that it will fly and not crash. Otherwise, what am I doing? That's the goal of the whole process is to output an artifact that I can be confident in will fly and will not kill people. Like that's the point. So if you're good at engineering, you have to be good at building systems where you can predict properties you care about. And the enemy to being able to predict properties you care about is complexity. The more complex a system is, and the worse you manage your complexity, the harder it becomes to accurately predict things. Like bugs are just unpredicted features, so to speak, right? And hacker access is almost always just unpredicted, user capabilities that weren't supposed to be there. So this ability to not predict what happens is also at the core of the AI safety and alignment problem. If we had a perfect, beautiful design for an AI where we know exactly what it will do, we know exactly how it works, we know exactly what its motivations are, like what actions it will take in the world, well, that solves the problem. Not the governance or philosophical problem, but it does solve the technical problem. Like if I know exactly what it will do and I can make it do anything I want, that is kind of by definition is a solution to the problem. And so this is not, and so sometimes when people talk about AI safety or AI alignment, it comes across as this impossibly esoteric topic. It's like super abstract, mathematical philosophy, no connection to reality. And I think this is a really bad framing, actually. It is a very hard and pre-paradigmatic form of engineering, but it is engineering. This is fundamentally the problem of engineering. This is fundamentally the problem of building complex systems that you can predict to do the things you want. And so, to bring us back to the slop problem, a lot of slop is complexity. It's just things are getting more complex and it's harder to get what you want out of a system. Now, if I Google something, there will just be a bunch of mediocre images drowning out the things I actually want. I can still find the things I want if I go looking. It's now just even more friction. It's even harder. It's more confusing. It's more things. And did the developers of these systems intend for this to happen? No, I don't think so. Like I don't think, people developing AI picture generators want it to permanently, pollute the entire Google system. I don't think so. But it was still the consequence of this. And so, and this goes back even further. So why do AI systems produce slop? So there's a bunch of arguments about why this is, right? It's like, oh, they just create the median product, which is always kind of bad. The RLHF messes them up. And I think there's truth to all of these. But I think there's one that I feel is underappreciated, is that slop isn't new to AI. Humans produce a lot of slop. And they have produced a lot of slop historically, and it was selected for by recommender algorithms. I don't know if you remember the early internet. But the early internet, where everyone had their own website and everything was human made and human curated before social media, before algorithmic curation, it was just a very different place. The vibrancy, the culture, the creativity, the uniqueness was just very, very different. And this changed when we had black box algorithms starting to select and modify the system in complex, immeasurable, illegible ways. And so this is complexity as well. Like this is also a problem. It's not that some guy at Facebook decided, I want to have an algorithm that, makes children watch these horrible, low effort animations that are on like YouTube or Facebook or whatever, right? Not that like they decided to do that. It's just an output of a complex system. And because it's a complex system, no one is ever at fault, right? Like if someone gets, if in some third world country, recommender algorithms select for hateful content that leads to a genocide, which is a thing that happened in 2017 in Myanmar, no one's at fault because Facebook would say it's the algorithm. How could we have known? It's too complex. We don't know. It's not our fault. It's just what people are doing. And so complexity shields from accountability. And so this is the most general version of the problem, so to speak.
Okay, so I would like to ask you something about the idea of complexity because I think what you just said about Facebook and YouTube is precisely correct. The guy who invented the like button was interviewed on the movie The Social Dilemma, and he said, I had no idea whatsoever that I'm unleashing hell, basically. And you're absolutely correct. But you said that complexity, the more complex a system is, the harder it is for accurate predictions. And what we want when we are building an airplane, that we want to be able to make predictions in the domains that we care about. Now, I would like to weigh in and put another notion, which is understandable. some of the things or some of the reasons that we cannot predict AI system is that we don't understand them. We don't know what the hell is going on inside the 100 billion trillion. There is no way any human being can grasp those numbers. That's 60 billion numbers of numbers. So if I cannot understand, I cannot predict. And if I cannot predict, I cannot count on those systems for life like mission critical. So where do you put the understanding in this entire context? Because maybe if we just work harder, like in the most complex piece of code ever written, okay? If we just work harder, maybe we can understand, but I doubt it. And Roman Yampolsky told me that OpenAI is working on AI safety and AI ethics because it has no idea whatsoever how to approach the AI alignment problem.
Yeah, so I think that you said exactly correct. Understanding is the thing that is missing. If we understand a system, we can predict it. If we can predict a system, we can actually build the thing we want. We can actually prevent the things we don't want and get the things that we want. That's the core of engineering. That's the core of progress. That's the core of technology, of science, of civilization. Is the ability to build systems that we know are good and do the things we want and don't do the things we don't want. And the core of the AI alignment and the AI safety problem and the AI ethics problem is to a large degree us not being able to predict the outcomes of these systems. I truly don't believe that people at Facebook are purposefully building racist algorithms or something. I don't think they're doing this on purpose. I think it's just complex. It's very complex. No one's in charge. And then just like, who knows, right? So, and with AI safety, I don't think anyone is building AIs to kill people on purpose, right? I don't think
Yes,
anyone.
but just a second, Conor, but you're not surprised. And this is a very interesting point. I think that you're not surprised that Grok by Elon Musk can, I will give you an example that I was witness to. You tell ChatGPT, please tell me a Jewish joke, okay? I'm Jewish and Israeli, I can do whatever I want. Tell me a Jewish joke. And he can tell you many, many very funny Jewish jokes. And then you ask him, in the same thread, in the same prompt, in the same, tell me a Muslim joke. No, I can't do it. It's too offensive, okay? Tell me an Irish joke. I can do it. Tell me, I don't know. So I can see it, okay? I can see. And you're not surprised that Grok by Elon Musk can produce Muslim jokes. Because maybe on some levels we can reverse engineer the inherent bias injected into those systems by the guys at Silicon Valley, not on purpose. Because again, Elon Musk, Grok by Elon Musk, is immutable to those PC things.
There is both, of course. It's not that we have zero control over our system. We have some control over our systems. I guess the core thing here is I'm pointing is that even Elon Musk cannot say ahead of time what will Grok do in a given scenario. This is the thing I'm pointing at. It's like there are some scenarios where I'm sure Grok will say things that Elon Musk wishes it wouldn't say, and he can't make it not say that. Or at least, maybe this one specific instance he can, but he can't guarantee that it will not happen in other circumstances. And this is kind of the core of the problem. Usually, as you build more and more complex software, you get to a point where either you manage the complexity very well, you have a very well managed code base, you do lots of refactorings, you know exactly what's going on, or eventually you kind of get to a point where it just breaks. It becomes so complex that you can't continue. You can't make it, you can't refactor it, it's too big. You can't fix the bugs, it's too complex. You can't add features, it's too complex. So this is what I call like software senescence. And this is kind of like the usual end of life cycle for like for example, a lot of like legacy software or like big like enterprise software kind of gets to this level where you have these massive software systems that many things depend on. Like we have banking software that's like still from the 60s and 70s that still runs on mainframes in actual banks. And they just can't fix it, right? Because it's just too expensive, it's too complex, it's too much of a headache, so we just keep it running. So this is like a software senescence. It's like it stops dividing. It's just old. You can't move it anymore. But the weird thing with AI is that AI is a bit different. where you can keep adding stuff to AI, even if you don't understand it. Even if you've long ago lost oversight of what your system can and can't do, you can still make it bigger. You can still create a bigger model, you can still feed it more data, and it will become more capable. So in that sense, if we go to the biology, analogy, it's not just software senescence, it's more like a software tumor, like cancer, is that it's immortal. It can always grow bigger. It can have more. It can become more complex and
Just a
not
second.
die.
This is great. This is great. What you just said. Listen, you can't add a piece of code to a 60 to a banking code from the 60s. It
Yeah.
just doesn't work this way. But in artificial intelligence, you can, even though you don't really understand, you completely not understanding the system, you can add more layer, you can train better, you can use a reinforcement learning human feedback. I know that you are a little worried about this, but you can make it bigger and you can make it in some ways better. And this
Yep.
is profoundly different than this traditional piece of software.
Yes, this is exactly right. And this is also at the core of the worry about AGI and ASI, is that in normal software, if we would using just normal software build a system that's as smart as a human, I think we would have to understand it very well. Otherwise, it would just break long before we got there. So I'm not worried about normal software producing AGI because we would have to understand it. But with AI, it's different. With neural networks, I think we can get to AGI and superintelligence without understanding it. And that's where the risk comes from. Because then we can't predict it, we can't control it, we can't understand what will happen, and then, the bad things, the consequences will
But
happen.
just a second.
Mhm.
But
Mhm.
again, you can't both hold the stick. You can't hold the stick from both ends because Jan Connor told me that he wanted, to work on this big intelligent thing. That the big intelligent thing will be able to solve many of the world's problem. And just like I and no one else in the world can predict what Connor will do next, I can predict with probability, but I don't know for sure. Some of the sparks of intelligence and creativity means that I cannot fully predict your outcomes and your way of thinking, etc. And if you strive for true AGI, it 100% implies that you cannot control the systems in, a, in the same way that you cannot control what Connor will think next. Maybe I can control what you will say next, but I can't control what you will think next. And if you want true intelligence, maybe this is a sacrifice we must pay.
So the thing I fundamentally care about in the world is not intelligence. I care about people being okay. I love humans. I love my family. I love my friends. I love everyone on Earth. I want everyone to be okay. This is the thing I care about. For me, technology is just a means to an end. It's a way to get human flourishing. What I care about is human flourishing. And if we need AI to get there, cool, great. All right, well, let's figure it out. If it leads to bad outcomes, then we shouldn't do it, right? So I do think that we can get intelligent systems and we can get better theories of intelligence and so on, and better ways of dealing with such systems that we can get good outcomes. If you build a system that is a million times smarter than a human and it doesn't care for humans, it's just random, it's just cancer, it's a tumor, then it will crowd out humans, it will outcompete humans, and it will get rid of them. Like tumors are not nice. They might be smarter than your cells because there's more of them. Look, they're reproducing faster. That must mean they're more fit and they're better. But no, cancer is bad. And so I wouldn't want all my friends and family to be, forcefully displaced or destroyed by a growing AI system of some kind. Now, does that mean we can maybe design systems in such a way that, for example, we can predict that they will follow laws or protocols or ethics that we endorse? Yeah. That doesn't mean I will be able to predict exactly, what quantum theory it will come up with. But I might be able to build systems where I can be sure that whatever quantum theory they come up with, they will use it to help humans rather than to harm them. This is the kind of what I would consider like solving the alignment problem. I won't know what theory these machines will invent, but I might be able to know that they will at least use those theories as well as they can to help us rather than harm us, if that's possible at all, which it might not be. But I think like we see this with civilization, right? Like humans are the most dangerous animal on the planet, right? Like humans are very, very dangerous, including to other humans. Like for most humans, there's no animal more dangerous than other humans. And so but in many places throughout the world, we, in most situations, are lucky to live relatively safe lives and cooperate with other humans in mutually beneficial ways and so on. It would be great if we could do the same thing with AIs instead of AIs steamrolling us, but that doesn't happen by default. If there was one human who was a million times smarter and a million times stronger than all the other humans, I think that would be very dangerous.
Okay, so I totally agree that artificial intelligence or technology is basically means to an end. But I think that people, people's nations are divided regarding what is the correct or the meaningful end. What is an end that we should strive for? Okay, we have current war with Gaza, with the Palestinians, between the Jews and the Muslims, and both sides consider the ends profoundly different. Okay. Now, you, I think, signed on a petition that don't do any research on any GPT stronger than GPT-4. Is it true?
Yes,
But
there was a 6 month
yes,
moratorium back in the day. Yes.
yes. But there is some very annoying thing called reality, and reality doesn't give a damn about this petition, And we have OpenAI, and we have Claude, and we have the China, and we have everything. And even though Mo Gadwet and many other researchers, and Roman Yampolsky and you, and even Jeff Hinton recently, screamed this over and over again. uh, ChatGPT 5 is currently being trained on right now as we are speaking. Okay, and so this is reality. And
Yes.
my question is, when you say in the short term, because you say, uh, uh, I think that the bigger problem in the short term is AGI, and you use the word short term. And many people, some of the audience that I have is layperson, and he's saying, why? I can understand if he would have said in the long run, in Matrix style. But could you please describe a scenario where this could be a major problem in the short term? Could you elaborate on the how short is the short term?
Course. I mean, ultimately, none of us know, but I mean, Sam Altman says it might be next year, for example. Dario Amodei says it's going to be by 2026, maybe. Other people tend to say someone between 2027 and 2030. Like I say, like 50% by 2030, if you have to ask
In the
me.
next 10 years, okay? In the next
Yes.
10 years. Okay, so
Let's say in the next 2 years.
what will be in the next 10 years? Because again,
Mhm.
a very naive question, and I think it is worth answering. You could always shut down the electricity. You could always plug it out. So what do we mean by short-term AGI? And again, this is not the matrix. This is something different, very different.
Yeah. So this is a great question. And so let me give you a counter question. When I say AI slop is not a problem because we can just turn off the electricity if it creates too much slop, do you think this is a good argument?
No, no, I don't think, because you say, okay, the extreme in the media is very bad. Okay, don't read the media. Okay, this is not a good solution. It's just like we have many car accidents. Okay, don't use cars. Okay, this is
Exactly. And
basically.
and this is the same problem with AGI. The problem with AGI is that everyone wants to build it and they're making trillions of dollars. Is like there is and these systems will be able to defend themselves, right? Once you have an AGI system that's smarter than a human, and it won't want to be turned off and it will know that someone might try to do that and it will stop you from doing that. Like obviously you would do the same, right? Once you have a system that is trying to gain power, to gain resources, whatever, right? Make money, who cares, whatever, then that system is smart enough to understand it needs electricity, right? It knows that, and then it can just make a plan to make sure you can't do that. It can upload itself to the cloud. It can pay people to protect it, whatever, right? It's like think when you think about an AGI, don't think about like a little icon on your screen. Think about a corporation. Like, think about the most powerful mega corporation that has infinite money, is smarter than everyone else, has all information, all surveillance, and whatever, right? How do you shut down Google or the United States government? Like, how do you, like, you could ask the question, how does the United States government hurt me? If I don't like it, we can just turn it off. But the truth is, you can't really turn off the United States government. Like, even if you tried, you can't. It will defend itself. And the same thing happens with an AI system. If you have a powerful enough AGI system, it will defend itself.
And I think I want to add that in a recent lecture, Jeff Hinton said that there is something that will always help AI systems to do what they are told to do, and this is get more power. So if AI systems is told to do something, and AI system want to do it in the best efficient way possible, one of the tools or sub goals is to get or gain more powers. And this is basically what you're referring to.
Absolutely. It makes sense, right? If you're just the most intelligent system, well, you want to do your thing. Well, you don't want the monkeys to turn you off. You want enough electricity, you want enough resources and solar cells and, whatever, right? So you just have to go get that. And if you're smart enough, you can go get that. The systems can and will just get what they need because they're smarter. It's the same way how, like, an adult will be able to outsmart a child. If you want a thing, you can just get it. And so these smarter systems will be able to do this, sooner or later, right? Like, it just kind of like it's kind of like humans and chimpanzees, right? Chimpanzees are much stronger than humans physically, right? So the chimps might say, we have nothing to worry from humans. We can just beat them up if they do something we don't like. But the truth is, no, humans control the planet, not chimps, because we're smarter. We have better technology, we have better coordination, and so on. And the same thing will happen if we have a system that's 1,000 times smarter than us. To them, we're chimps.
And again, the DNA, the shared DNA between chimps and human beings is 99%. So just 1% of difference in the DNA, whatever that means in artificial neural network, means the world, okay?
Yep.
Just 1% of DNA differences between chimps and human beings. So
Yeah,
again,
as an even
yeah, please.
funner statistic, humans and chimpanzees have almost exactly the same brain structure, basically. Like, our brains look basically identical. Ours is just scaled up by a factor of about three. So if you scale up the number of neurons in a chimp brain by about 3 times, you get about a human brain. So meanwhile, our neural network systems, we scale up by 10 or 100x regularly.
Okay, so, and let me quote Jeff Hinton again. Jeff Hinton said that, my most accomplished achievement is that my student tried to kick out Sam Altman from OpenAI, and he of course referred to Ilya. So the idea is that I don't want to color the bad versus good guys, because like in the like button on Facebook, most people, I think the majority of people at OpenAI have good intentions. I truly believe it. But in your opinion, what should happen next in the next 2, 3, 4 years, and what will happen next? And would you say that now in with Elon Musk news in the White House, we will see any major shift in uh, AI alignment or addressing AI alignment problem uh, from the U.S. governmental perspective?
Yeah, so there's a lot we could talk about here, right? From what obligations do people at companies like OpenAI have, morally speaking, versus not, versus, how much do people like Sam Altman really matter or not, to, so on. And so there's a lot we could talk about here, but I guess just a couple thoughts here that might be, and be interesting for this, and then I'll talk about what I think should happen and like what I think will happen with Musk. Um, the general thing is that complexity shields people from accountability. One of the things I've learned very deeply in my life from talking to very powerful people all across the world, very smart people, very rich people, also like not rich, also like very poor people, and like people from all across the world. One thing I've learned is that most people are absolutely cowards, just unbelievably cowardly. Like across the board, across social, across genders, across everything. Just most people are complete cowards and they are terrified of being accountable for anything, for being blamed for things, for being responsible for anything. And so there is a lot of optimization pressure in our society goes into into obfuscating responsibility. And a lot of bureaucracies, for example, have this shape where, like let's say your phone company messes up something, right? And so you call the helpline, right? And it's some poor guy he's not in charge, right? It's not his fault that it broke, right? So you can yell at him if you want, but it won't help. So no one's at fault, right? Or there's some huge project goes wrong at your company, but then there's seven managers and they all blame each other, right? Who's responsible? Who knows, right? So there's a lot of systems like this that optimize to make sure they're responsible, right? Let's take the guy at YouTube, right? He makes the like button, he puts it in, it causes massive damage. Is he responsible? Do we throw him in jail? Like in our society, we don't because we say like he couldn't have known, right? It's not his responsibility. But that's the problem. So who do we throw in jail, right? Like there are children whose mental health is being permanently destroyed by like YouTube recommender garbage. Someone should go to jail for this. Who? And the answer is right now, no one. No one is being held responsible. No one is going to jail. And if we run our society like this, then the cancer keeps getting worse. If our immune system doesn't work, if no one is ever held responsible, if no one is ever punished, then the things just keep getting worse. And I don't know if you've been on social media lately, but they keep getting worse because no one is responsible. No one, there's no, what would it even mean to be responsible for that, right? Like, who measures that? Who decides that? I don't know. I'm not saying I know how to fix this. I'm saying this is a massive problem because obviously there's something is wrong. Obviously people are getting hurt, but like, we can't figure out who or why because it's too complex. The system, the whole social technical system is so complex. And so this brings us back to OpenAI. You're an engineer working at OpenAI, and
Just a
you're
second,
working on.
before OpenAI, I want to give another example to my viewers. Let's say
Mhm.
that you're the CEO of an investing company and you made a great profit last year. You get share of this profit. But if you made a great loss, you have no accountability whatsoever. If, on the other end, you would have to pay a share, a specific share, giving that you made a loss to your clients, I think everyone is sure that some of your algorithms in investing would have been profoundly different. And this is
Yep.
basically what accountability means. Okay, put your mouth where your money is, or etc.
Yep.
So this is
Yes.
very, very important.
Yes, I agree. And so much of Silicon Valley, big tech is optimized to prevent people from having to put their money where their mouth is. And no one ever getting like responsible or like being hurt. Is like creating GPT and releasing it has caused massive damage to many, many people. It has shit up social media. It has increased propaganda and polarization. And like, there are many, many harms that were caused from this, right? There's many, many harms. Also benefits. I'm not saying there aren't also benefits, but there are many harms. And my question is, who is paying for that? Does the engineer at OpenAI go to jail if someone gets hurt from ChatGPT? Well, no, absolutely not. So he has no incentive. He has no accountability. There's this crazy thing where I was once talking to an open source guy on Discord server on Eleuther AI back in the day, and I recently said that I think like developers of AI systems should be liable if like harm gets caused. And then he called me out. He was like, Connor, but you have developed AI systems in the past. do you want to be held accountable if someone misuses your AI system? And I was like, yeah, yeah. I would love to live in a world where if I, as an engineer, produce something that harms people, then I am held accountable to this because that's how we get good systems that are actually good for people. Like, so what's happening right now instead is you have like Stanford grad students developing like, voice cloning systems, which are obviously used for fraud, and just putting them online, for all criminals to use, and there's zero accountability. And they don't even feel responsible. When you say, hey, it seemed like that might be a bad idea, they're like, oh, are you against, you some kind of fascist, or it's free, it's open source, it's good. So there's this very childish attitude that is very, very common, especially in tech. Where just like these people believe I should be able to do anything I want to do. I should be able to release, to say, to make anything, no matter who gets hurt. And I should never face responsibility for this. They won't say it in these words, but you see it again and again. When recently there was a law in the California Assembly called SB 1047, and it was an AI safety law, and it's a very mild law. In particular, it said only liability, only for catastrophic scenarios with more than $500 million of damage. And it's like a very small amount too. And so if you cause $400 million of damage, no liability. And this law, all the tech companies fought like as hard as possible. They tore it apart. They screamed and they screeched that it will destroy innovation. We can't do that. And I'm like, huh, if you can't make products that can't guarantee not do $500 million of damage, maybe you shouldn't be making products, you know? Like, so there's this strong attitude, and you'll see this at OpenAI and so on as well, is that these people just want to build cool shit. They don't give a shit who gets hurt. They don't give a shit how it affects the world. They don't give a shit. And they're trained to not give a shit. That's not, and now we can say, are these people good people or bad people? If you meet them, they're lovely. Like these are lovely people. Some of them are my friends. They're fun, they're interesting, they're smart, they're building cool stuff.
They
But
have good intentions. They have good intention. I think, uh, Immanuel Kant, this is the father of the secular moral theory of ethics. And he said the things that count about morality is intentions. And I think, and it may be problematic to say, that many of these guys in Silicon Valley are unaware of the fact that some people do not think like they do.
so
We
so
have,
just
yes, please.
sorry, just I do have to challenge this. I don't think intentions matter whatsoever for morality. I think this is just it just doesn't care. I disagree with Mr. Kant there. I haven't actually read him, so I don't know if this is
Because you
true.
have a Jewish soul. According to the Jewish morality ethics, you are absolutely correct. Intention has nothing to do with this. Very good. But according to Kant, if you did good deed, but your intention was bad, this is a bad deed. And if you did a bad deed, but with a good intention, so you made a good deed. And this is, again, this a construct of morality was injected into Western society. And this is very, very important. And this is why we, in this podcast, we would like to sometimes distinguish between Athens and Jerusalem, between Western society and Jewish society, and say, we need to incorporate both. And what you just said is a Jewish way of thinking. Very good.
I didn't know that. That's very interesting. I think this is a great way of thinking, and I would love to have more of it in our society because I think it's exactly correct. If you do good things, that's all that matters. I don't care what's in your mind. I don't care if you're happy or sad about it. If you do good things with good or bad intentions, it's good. And good intentions don't excuse bad outcomes and bad things. And I think the real reason why people do this is mostly because of cowardice. It's just they want to do something fun, they want to do something easy, they don't want to do something that's scary or something, or like having to think about the consequences, which are complex. So, a big part of what corporations do is that they manufacture complexity to hide from the engineers the bad outcomes of their effects. So there's this effect you see a lot in these big corporations where you have the sociopath like executives who know the bad consequence and don't care, and then they will shield the engineers from knowing the bad consequence. Not always, but like this is a common pattern where they say you're changing the world and making it better because of innovation, while they know that like people are dying and they don't care.
I think that what you just said about the $500 million damage that all the tech company were sued against, uh, this is something one needs to think about. If
Yeah.
a tech company cannot assure that the product it brings to the market will not cause a $500 million damage, maybe they shouldn't build it.
Yep.
Wow. Again, my I made a policy with myself that I come to those conversation in a mode of listening and learning something new. It's not a debate. It's more a conversation that I let myself change my mind. Okay, and wow, this is. I think it makes everyone think. It forces everyone to think about the consequences of
There is a
what we are
deep,
doing.
exactly. There's this deep thing where like I look at people in the Bay Area in these tech companies and so on, and they remind me of how I was when I was a teenager. I used to be like this too. I had really good intentions all the times, always. I always wanted to do good things, but I did a lot of stupid things that hurt a lot of people. Not a lot of people, but I was, sometimes rude or I did something which was maybe irresponsible and stuff like this, like every teenager does, right? It's normal. But you usually grow out of that. And eventually you see your actions do have consequences and you have to get along with other people in your society. And this is actually very important to respect other people and their, stake in the general world and their safety and even if it can be very hard sometimes. But that's what it means to be an adult, basically. And if you ask me, the what makes the Bay Area, like different is that it kind of optimizes to prevent people from becoming adults. It like optimizes so that you can just stay a kid forever. You don't have to worry about the consequences. That's too complicated. So I think that's a lot of the heart of the problem.
And this is why many of these guys in Silicon Valley, we have PlayStations and we have Xbox and we have all the thing, all the gadgets that basically it's just a playground.
Yep.
And this playground has no consequences whatsoever. But the consequences are can be horrific. But again, what is the alternative? What is the alternative? Because
Yeah.
I just wanted to ask you, let's say that a
Hmm.
young engineer or a young enthusiastic student uh, just heard the entire conversation. He said, okay, I want to be
Hmm.
like Connor. I want to reverse engineer GPT-2 or GPT-4o or GPT-O or Claude 3.6, etc. And this spark of creativity and the pleasure of finding things out, as Feynman put it, is what drives innovation, creativity, technology. And I think we need to find a border where we let the kids play, just run and play, but later on, we as an adult or as a adult society say, okay, just a second, very good, thank you so much, but now we need to think or rethink about it. And I think this is what happened with calculus. Newton and Leibniz had this great intuition, and they didn't have rigorous proof. And all the math of the 18th and 19th century was to come, step by step after Newton and Leibniz to say, okay, let's make sure that everything is pure 100% solid. But we had to have those 2 or 5 or 10 or 20 visionaries to run first. And I think that we need to know how to balance those two tendencies. Would you agree?
Ab Absolutely. I think so for me, the way I think about this is I think this is kind of like at the heart of the tension between like entrepreneurship and statecraft, building states and like great states, good states, is that I think there's this pattern of you need to do exploration to create new things, to find new things, to create improvement. This is extremely important. Entrepreneurship, science, art, these things are very important. And any society that strangles these things will wither. Like it can't succeed. But there's another side where if you have no constraints on, or no rules of engagement for entrepreneurship, science, or even the arts, they can go very bad and they can create very terrible things that can just infect and destroy your society. And I think this is a lot of the heart of what a state is for, what a nation or a government is for. The reason we have regulations on the market is to say, all right, look, here are the fences. You're not allowed to cross those. No killing people, no fraud, no poison, pollution. But other
No
than
deep
that,
fakes.
no, whatever, right? Exactly. But other than that, go crazy, invent crazy products we don't even know yet. And this is how things should be. And this is how things were. Like this is how things were for most of, modern history. Like when we remember, good times of the 20th century, a lot of bad times as well, obviously, but like, and we consider like 1950s 1960s America as like this like golden age of like government capacity where there was this deep integration between science, industry, and the government, and they were like three parts that were working together very, very closely to produce
But we
these.
also had the Cold War, which
We also had the Cold
was
War.
the I think
Mhm.
the strongest motivation for all the good things that you just mentioned. Okay,
Mm,
we had the science and the technology, and we had everything, but we also had, and you cannot bypass this. This is immense. We had the Cold War between two
yep,
giant, between the
I
U.
agree. Yeah,
So,
no, I mean you're right. Like to be clear, we have never had a true golden era where there were no problems. Never happened. We have had golden eras in various aspects of our society or in various bits and pieces of it, but we haven't solved the big problems. At some point, we as a species have to find a way to get along. We have kind of figured out how to get along on like a nation scale, right? Like nations nowadays are usually pretty stable. Not always, not in all circumstances, but like much more than they were like the Middle Ages. But like global, it's still not stable. There was the whole end of history thing, and that's like not really looking so hot right now. We'll see. And the Cold War is really fascinating in this regard, in that the Cold War was massive. It was one of the largest risks to humanity's ever, but it didn't become a hot war. And that is crazy. It is actually crazy that there never actually was a final war between the US and the Soviets. In any other point in history, there would have been. France and
but
Germany, or whatever.
I will tell you two things. One, it happened 10 years after World War II. So
Yep.
we had a very big war. And second, we were very close to open a
Yes.
nuclear war between the US and Russia because in order to launch the nuclear missiles, we need to have two keys and to
Yep.
switch them simultaneously. And we got to the position where the keys were already in the switches. So we
Yep.
got I know that you don't believe in God, but thanks God or thanks whatever you want to thank, we were very, very close to start or to initiate a nuclear war between the US and Russia.
Oh yeah, I mean to be clear, I totally agree with this. It could have gone differently. I'm not saying this was guaranteed. I'm saying it's a miracle. Like thanks God, or whatever force, ultimately caused this to not happen. Like you are correct. I think if we reran history, it wouldn't go this way every time. And that's also like I want to be clear here. Like I've been putting some optimism here. I don't think we're going to survive AI. I don't think it's going to go well for the exact kind of reasons you're just describing. Even with much simpler problems that are much less complex, like nuclear war. Everyone knows not to do nuclear war. It's fully in control of humans. We know exactly how nukes works. Like we really do understand nukes. We actually understand them very deeply. And we know how they work. They're in control of states. They're not like wildly proliferated, I mean, a little bit now, but like it's not like every private person has their own nuke or whatever, right? So like it's like kind of like a best case scenario. It's like a thing we understand very well. Everyone knows that we shouldn't fire them if we can prevent it. It's only in control of like powerful nations which have like lots of checks and balances, allegedly, hopefully. And even then, we barely made it. And now how will we handle something that is way more complex to understand, is distributed across the internet, across the market, across everywhere, where people are not in agreement whether this is good or bad, or if there's even a risk at all, or maybe the risk is worth it. That is a much, much harder problem. And so I don't want to like lie to your audience here by any means. I don't think we're gonna make it. I think it looks really bad. I think I'm obviously going to try as hard as I can to make it go well, but I don't think we're on a good trajectory right now.
Which reminds me, I think, Einstein phrase about, I don't know how World War III will look like, but I know that World War IV will be fought with sticks and stones. Okay? Okay, so if we don't have much time, so in the in the meanwhile, and uh, if you can just forget some of the things that you told me in this conversation, and I want to ask you one last question. Nowadays, we Andrew Karpathy that explain via YouTube beautifully how to reconstruct, how to engineer, reverse engineer, how to make GPT from scratch. And we have 3Blue1Brown with his great LLM tutorials. Okay. And those things were unavailable to you in 2019. Let's say that I have a student or enthusiastic student that wants to go to the next level and that wants to run, but unfortunate for him, he already has Andrew Karpathy and 3Blue1Brown. Let's say that he went over those tutorials. What would be your recommendation for the next step?
Yeah, so there's two ways I can answer this question. I'm going to answer them both. One is like how do you get more technical, and what do I think they should do? Those are two different things.
And
So
and 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 please, how to be more technical when being technical is very hard because again, you always can ask Copilot and GPT, and you
Mhm.
have all the tutorials in the world. So maybe this richness of
Mhm.
code and information might blow up your creativity and your desire to be more technical.
Yep. So I think this is a problem. I, to a degree, envy and to a degree pity current students. I think this is both a blessing and a curse. I think the one thing I would just this is the same recommendation I've given for people like throughout my whole career. I'll give the same recommendation again and again. Build actual things. Build real things, real software that you deploy into the real world that does a real thing. Doesn't really matter what it is. You should also build software that is not an AI. Like if you want to get really good, if you want to be someone who is good enough to, solve AI alignment or build AGI, you need to write a compiler, write a router, write a memory management software. You need to understand, you need to like know how to do classic algorithms. You need to know how to make a website. You should have deployed an app to 100,000 people before without it crashing. You should be able to, use Kubernetes without instantly wanting to kill yourself. Like not because you will need these specific things, but because by doing many things, by being a jack of all trade, you can develop a sense of what it means to do computing, what it means to build software. Because the thing at the core of software, the real thing at the core, is a abstract science of solving problems, an abstract science of building complex systems and managing their complexity. And by building complex software, running into the problems that you will run into. The first time you try to build a video game or whatever, you're going to see that you're going to do it really poorly and your code will be completely unmaintainable. And then you should ask yourself the question, what did I do wrong? How can I do better? How could I have architected my code differently? How could I have managed this complexity? And then you could start looking at what other people have done. You can start reading books about what other people have done, or at least asking Claude, to explain to you software architecture and like how you do these kinds of things. This is the thing, Oregon, is that tutorials are great, but you should ground yourself. Like the thing that was the most useful thing for me to reverse engineer GP2 in like pure technical capacity was that I had to do it myself. And I had to like actually do it. I had to like actually scratch. I had no idea how to scrape stuff. I never done it before. But I'm like, well, guess I'm figuring it out. So this feeling of like oh well, I'll figure it out is more powerful than any like academic skill that you'll learn. Paul Graham has a great essay which is kind of about a related thing, which he calls relentlessly resourceful, which is like this property that you can have in like startup founders and more general people. It's just like you'll figure out a way. Like no matter what the problem is, you'll figure it out. And that's what you want. That's the thing you want. And you can get it by just actually doing it. But if I could just add one more piece to this, the one more piece I would add to this is that the world doesn't need more brilliant tech people who can just sit in a box and build something that no one wants or needs or even makes the world worse. What people need are brilliant tech people that can make the world a better place. And this is harder. And to do this, you need to do more than just be a really good programmer. You also need to be a great programmer. You also understand computation, but you also have to be a good communicator. You have to be able to talk to people. You have to be able to manage people. You have to be able to understand people from a different point of view. You have to be able to manage your emotions and the emotions of other people. You have to be able to have sympathy, to give orders, to take orders. You have to be able to understand politics and economics and like why things are the way they are. You have to be able to negotiate. You have to be able to, think about externalities and so on. And this is very hard. Like I always recommend everyone should do a class, at least an introductory economics course. You should know what market failures are and when they happen. You should read some history of whatever, really. It doesn't really just read actual history books about, don't ask ChatGPT, read actual history books. Try to understand people and like where ideas come from. And if I could say one more thing, which I think is, considered old fashioned, call me old fashioned, but engaging in political and civic life that is not on social media. Like showing interest in your local community or your political parties or so on that is not on social media, that is not screaming on people, but rather like trying to improve the process and understanding the process of how process things are made. This world needs smart people. We need smart, brilliant young students who care about improving their government system, about improving their local society, about understanding the consequences of the system they build. This is the thing I would really advocate for.
And which are willing to take responsibility. I think this is a
Yes.
very important thing.
Yes.
The
Actually,
idea
if I could
of
say one more thing on that, it's just like to all young students potentially watching this, one thing I wish I would have understood while I was younger is that people want you to take responsibility. If you're willing to take responsibility, you can get really far in life. You can get really high up, you can get lots of respect and power and by being responsible, by being someone who's worth trusting, like holding your promises, being reliable, and being willing to take risks even when they go wrong and then being not hiding that they went wrong but like owning, okay, it went wrong, here's why, I own it, I messed up, and so on. People respect this, and these are the kinds of people that we need in the world.
definitely, I couldn't agree more. And just regarding the first phase or the first part of what you just said, I once attended a startup conference in Israel, and the lecturer there said that we Israel are very optimistic, and he defined optimistic as a very I remember the definition. Let's say that you are trying to hack a device, which the things that you want to do is not on the data sheet, and you contact the company, and the company say you cannot do this with our device, and you say yes, I can. So this is a basic thing of optimism that many Israeli in the startup industry have maybe too much from it, but we are very optimistic and yes, we will figure it out. Conor Lay, thank you so much for your time and your wisdom, and you really got me into thinking again about many of the things. And I will, since I also a professor at the university, those wisdoms will be conveyed to my students as well. So thank you so much. It was a mind blowing experience.
Thank you so much. It was a real pleasure.